So the purpose of this video is to go over these practice test problems. I'm going to go over 1 through 15 in part 1, our practice test review, and I'll go over the rest of those in the second part. For each one of these problems, what I've done is I've put the section that the problem comes from. This is an old test that I gave a few semesters ago, and it's a great study guide for your test. On chapter 1. If you know how to do these problems and the concepts here, you'll be in fantastic shape for your first test. So let's get started here with our first problem. This is from section 1.1 on scientific notation. And what we're going to do, we want to convert 2.59 times 10 to the negative 6 as a decimal notation. So I'm going to write out 2.59. I'm going to move the decimal over 1, 2, 3, 4, 5, 6 places to the left. Come up with a very small number because a negative exponent indicates a small number. My answer would be choice E. So there is number 1. Number 2, writing this number out as scientific notation is also from section 1.1. Decimal is here. 1, 2, 3, 4, 5, 6. My A value is between 1 and 10. 6.7 is between 1 and 10. Move the decimal over 6 places. Positive exponent, because that's a big number. My answer is choice D. Number 3, which of the following values is the greatest? I have a decimal, scientific notation, decimal, scientific notation. Let me convert these two scientific notations to a decimal, then I can compare these using the number of zeros after decimals. 1, 2, 3, 4. So 0.0005 has 3 zeros, and 1, 2, 3. That has 2 zeros after the decimal. Now, I have all of these values, and I have to make a choice. Which one of these is the greatest value? That would be choice D, because that only has 1 zero. The other values have more zeros after the decimal. Now, let's take a look at number 4. We're finished with the review for section 1.1 on scientific notation. Let's take a look at question 4. Here's an after Christmas sale for bikes. This is out of section 1.2. Notice I've sort of marked up this problem to tell myself what type of problem this is. I'm looking for the sales price of these bikes, so I go right to this formula right here versus my markup formula. The problem will indicate what type of problem it is and what formula you have to use. So originally, this bike was $250. It was reduced 40% off of $250. So there are my values in the formula. I'm going to move the decimal over 2 places. So that would be 250 times 0.40 times 250, or 250 minus 100. When I multiply those two values, I get an answer of the sales price of the bike is $150, choice A. Here's how you would do that one from start to finish, starting with the formula. That formula is huge because if you have the formula, everything is just plugging and chugging and going to town. Let's take a look at number 5. This is also from section 1.2. This is a wholesale price markup problem because this is a sales tax. A sales tax is a government way of marking up a purchase of some items. So we're in Walmart and we have a cart full of items that is $135.56. And what we're going to do, we're going to mark these up 5% because of the sales tax of $135.56. So there are my numbers in the formula. I'm going to move that decimal over 2 places. So I have 135.56 plus 0.05 times 135.56. Copying 135.56 plus $6.78. The total price, including the sales tax of the items, is $142.34. My answer is choice B. So there's how you would do that one from start to finish. Again, the big part is getting the right formula. Everything else is pretty straightforward with plugging the values in. Same for number 6 out of section 1.2, a markup problem. I see the markup. I'm looking for the wholesale price. So the retail price of the lawnmower is $550. This is how much we would pay for the lawnmower at the store at Lowe's, let's say, $550. We're trying to figure out how much Lowe's paid John Deere for the lawnmower. They turn around and mark it up 45% of the price they paid for it before they sell it to us. I'm going to move the decimal over 2 places. So I would have 550 equal to x plus 0.45x, an understood 1 there. 550 is equal to 1.45x. I'm going to divide, and where did that 1.45 come from? I added those two terms. 1 plus 0.45 is 1.45, and the x is a like term. So I'm going to divide both sides by 1.45 to solve for x. Those are going to cancel out. So the price that Lowe's paid for this lawnmower was $379.31. They marked it up to us at $550. So there's your answer for number 6. Number 7, another problem from section 1.2. This was a sales price problem. I want to find the retail price after it was marked down 30%. So marking this up hopefully will trigger some values to plug into the actual formula. So this price was $135.50, the sales price. The retail price here is what I'm looking for, X. After this has been discounted 30% off of some value X. So let's say we go on Amazon and we see this sales price. It was marked down 30%. We want to figure out what Amazon paid for this jacket before they marked it up and put it on their website for sale to us. So we have $135.50 is X. Move the decimal over 2 places, minus 0.30 times X. And just like the problem previous to this one, there is a 1 in front of that X. So I have 135.50 equal to 1 minus 0.30. For a dollar minus 30 cents is 70 cents. 0.7 times X, a like term. Finish this off. I divide both sides through by 0.70. So my X value here is 193.57. There's what I would have for that one. So that was the original price of the jacket before it went on sale to us at $135.50. Take a look at number 8. This is where we started talking about linear models and finding the slope of a line between 2 points. Here are my 2 points, and here's the formula that's going to allow me to do that. This is from section 1.4 on linear models and slope. So here are my 2 points. I have the second y coordinate from my second point is 6. I have my first y coordinate from my first point, which is -2. X2 is 6 minus x1, which is 2. So what I have here is 8 over 4, which is 2. Got to be careful with the positive and negative signs. 6 minus a -2 is like 6 plus 2 or 8, and 6 minus 2 is 4. My answer is choice D. Start to finish the formula, what is the slope between 2 lines? There's how you do that. Number 9, let's omit that one. Let's take a look at number 10. This is also from section 1.4. What we have here is a graph and a model. And I want to know, if I were to graph this model, what type of graph would I get? So I see this x, it's not squared, so this is not quadratic. It is not as an exponent, so it's not exponential. There's no logarithm there, so this would be a linear model. So this linear model is either going to slope up or slope down, and it's going to slope down. It's decreasing because of my slope right there is -4. So decreasing linear model would be my answer. That one. Number 11. This is also from section 1.4. A salesperson weekly commission-based salary is given by this model. And what I want to do is figure out what this model means. So here's their weekly salary. They're guaranteed $300 if they sell no items. But if they start selling items, their salary increases. It's like an incentive for a salesperson to make sales. So let's interpret this model for what it would mean. My answer would be choice C. They start out at $300 and they get an additional $40 for every item that's sold during the week. My answer is choice C. Let's take a look at number 12. We're going to use the same model again. So the same model again, we want to figure out what the salary is going to be after 25 items have been sold. So the salary after 25 items is $300 plus 40, and wherever I have an X, I'm going to plug in a 25. So the salary for 25 items sold is $300 plus 40 times 25. Salary for 25 items is $300 plus 1,000. My answer is $1,300 for choice D. There's how I would work that one. Now, number 13, we're going on to section 1.5, and we're taking a look at a quadratic model, and I want to find the vertex of the parabola that this quadratic model will give us. It all starts with the vertex location, the x coordinate, my a value, and my b value, and my c value. I really don't need the c value for anything. I just wanted to be complete and mark that up. Here is my formula for the x coordinate of any parabola. My b value is -8. I cannot forget the negative sign from my formula. So minus a -8 over 2 times 2. So I would have 2 negatives become positive. 2 times 2 is 4. My x coordinate is 2. Finish this problem off. My y coordinate. I have my model, and wherever I have an x, I'm going to plug in a 2. So I have 2 times 2 squared minus 8 times 2 plus 9. This 2 gets plugged in to the model to find my y coordinate. Now, all I have to do is say 2 squared times 2 minus 16 plus 9 is 8 minus 16 plus 9. And when I do that, I'm going to get a y coordinate of 1. So my answer, the x coordinate is 2, the y coordinate is 1, and there's how you'd solve for that problem. Let's take a look at number 14. What I have for number 14 is from section 1.5, and I want to work with the model from the previous problem. 2x squared minus 8x plus 9. What I want to do here is I want to determine, if I were to graph this, what type of graph would I get? This time, x is squared, so that tells me a quadratic, that tells me a parabola. A is a positive 2, which means that this parabola is going to open up. So my answer for number 14 is C. Last one for this video, number 15. I have a quadratic again. If I were to graph it, what type of shape would this be? Again, my x is squared. My a value is positive 5. So this is going to be a parabola that opens up. Quadratic model with a parabola that opens up. Next video, we'll do questions 16 through 25.